Welcome back, guys. So in this lecture, we are going to see fourth chapter in your science textbook, that is carbon and its compounds. So for your board examination, guys, those are writing in 2021, few concepts are deleted, but I don't want to delete these concepts and I don't want to go with only few concepts. I'll explain full chapter. So in this series of lecture, total 8 to 10 lectures let us take. In this 8 to 10 lectures, let us see all concepts, all formulas in this chapter, and in-text questions, exercise questions. All we are going to cover in 8 to 10 lectures. You are going to get 100% concepts from this chapter. I don't want to leave any concept. So if you have a glance over the chapter, this small introduction you will get, then small activity, of course, I'll explain you. 4.1, that is the first topic, bonding. Today we are going to discuss regarding the bonding in carbon, that is covalent bond. There are two types of bonds. In third chapter, metals and non-metals, you might have heard about ionic bond. Now in this chapter, let us see covalent bond. What is the difference between ionic bond, covalent bond? Both I'll explain you in this lecture. If you have missed ionic bond in third chapter, metals and non-metals, all these concepts I'll explain. And next lecture, we are going to see bonding between atoms. Here we are going to discuss single bond, double bond, triple bond. Single bond in hydrogen, double bond in oxygen, triple bond in nitrogen. So what are these diagrams? How to represent those diagrams? What is the meaning of this cross X? What is the meaning of this small hyphen dash? I'll explain you. And what is this electron dot structure? How to represent this electron dot structure? This is the electron dot structure of methane, that is CH4. And how to represent electron dot structures for different elements, like elements and compound molecules, like for CO2, how you can represent, for H2O, how you can represent, NaCl, how you can represent, MgCl2, how you can represent, that and all we'll see. Of course, this NaCl, MgCl2 related to ionic bond, and these are covalent bonds. Let us check that. And allotropes. Allotropes means same element if you are finding it in different forms. Carbon is the compound you can find in form of graphite, you can find in form of diamond, you can find in form of C60, nothing but Buckminster Fullerens. I'll explain you what is this, shape, everything. And there are few in text, we'll see that later. Versatile nature of carbon. Why carbon is so versatile in nature? Why it is important for us to learn about carbon? Why we are reading only about carbon, and why a chapter is dedicated to carbon in your 10th class? You need to understand the importance. In your 10th class, if you find chapter names, chemical reactions and equations, acid, bases and salts, metals and non-metals, periodic classification, like that we have chapter, but only chapter carbon and its compounds. You are not getting any like oxygen and its compounds, hydrogen and its compounds, like that. Why we are getting only this chapter? Let us understand that versatility of carbon. We'll see all these 2 points. These 2 points are important. I'll explain you in third or fourth lecture. Then here comes, you see, chemistry you can divide into few parts, and in that one of the most important parts is organic chemistry. You might have heard in degree or in your 12th class, you will get organic chemistry. And of course, you will get inorganic chemistry, physical chemistry, etc. Organic chemistry, purely it will deal about uh, carbon. So there, new topic will be introduced in your 10th class, saturated. What is meant by saturated? What is meant by unsaturated? First, let us understand saturated and then unsaturated. Later on, we'll see saturated carbon compounds, unsaturated carbon compounds. You can find all these structures. Don't worry, if you understand today's concept, all these diagrams will be important and easy for you to denote, notate, represent, draw. Fine. So why they are representing C dash C? Here, if you observe this diagram, H dash C dash C dash H. Basically, that is not dash, it is bond. Bond. You have to call that dash as bond. Here you see C bond C. Here H bond C, C bond H, like that. Here we have one line, single bond. Here we have two lines, double bond, like that. Here if you find, sometimes you can find three. So all these diagrams I'll explain you. And this is main important, functional groups. Functional groups. What is functional group? How you are adding functional group to the carbon compounds. So there are few functional groups in the 10th class. You are going to learn only 5. Halo, alcohol, aldehyde, ketone, carboxylic acid. So how these are arranged, that and all we'll learn. And homologous series. We know what is meant by series. In mathematics also we'll get, in physics also we'll get series. What is meant by homologous series? In biology you might have learnt about homo. So homologous series. Let us break down those words and let us understand those topics. And nomenclature. Nomenclature. Very important for your higher studies. These all topics I have deleted, this nomenclature, everything, but I don't want to stop teaching. I'll explain everything. And here, how to represent alcohol, how to represent aldehyde, ketone, not only all the alcohol, everything, propanol, methanol, butanol, all names you will get, different structures you will get. I'll explain you. After that, we'll see chemical properties of carbon compounds in this chapter. You know physical properties and chemical properties. In metals and non-metals, we have seen chemical properties of metals and non-metals. In acids and bases, we have seen chemical properties of acids and here metals and non-metals. We have seen acids, bases, chemical properties. In this chapter, we are going to see chemical properties of carbon. So here, what is meant by combustion? Example. Second, what is meant by oxidation? Examples. What is meant by addition reaction? Examples. What is meant by substitution reactions? Example. And there we will get hydrogenation of oil. That and all we will see. You might have idea regarding ghee, vanaspati, dalda. That and all we will see. And very important, some important carbon compounds. 2 compounds we are going to learn in 10th. Ethanol, known as alcohol, ethanoic acid, vinegar. So we'll see properties of ethanol with all chemical equations and how alcohol is used and how you should not use alcohol. That we'll see. Properties of ethanoic acid. And the last topic is soaps and detergents. How soaps are manufactured, how detergents are manufactured, why we have soaps and detergents. For our body to bath, we are using soaps. To wash cloths, we are using detergents. What is the difference between that? Basically, why soaps are used? What is this structure? Missiles, everything we learn. From that, we can end the chapter and we'll see in text and exercise. This chapter is so useful in your 11th, 12th classes. Let us see introduction for this chapter and we'll try to understand what is meant by covalent bond, not only covalent bond but ionic bond also. Okay. We have 118 elements, and we know out of this 118 elements, 6 elements are stable, and 6 elements, sorry, not 6, nearly 112 elements are unstable. All these 112 elements will be trying to get stable. Now the concept is how it will try. How it will try. In ninth class, atoms and molecules chapter or structure of the atom, you have seen concept that how means there are two types. First one is by transferring electrons. Second concept is by sharing electrons. Two ways are there: by transferring electrons, by sharing electrons. Transferring electrons in the sense either by losing electron or electrons, or by gaining electron or electrons. Few atoms will lose electron to get stable, few atoms will gain electron to get stable. And let us try to talk about carbon today. This transfer of electrons or losing gaining of electrons known as ionic bond. Ionic bond. We have seen few examples regarding that ionic bond. We can take example of NaCl. You can take example of MgCl2. Okay, sodium chloride is ionic bond. What is meant by ionic bond? Either you have to find losing of electron, or there should be gaining of electron, or both you can observe. Let us see sodium chloride. Sodium atomic number is 11, chlorine atomic number is 17. 11 is not stable. What is the nearest stability element is 10. You know electronic configuration of sodium: 1s2, 2s2, 2p6, 3s1. Well, coming to chlorine, you know electronic configuration: 1s2, 2s2, 2p6, 3s2, 3p6, not 3p6, it is 3s2, 3p5. So you can write electronic configuration for carbon as 1s2, 2s2, 2p6, 3s1, or you can write electronic configuration as 2, 8, 1. What is this 2? 2 electrons here. What is this 8? 6 plus 2, 8 electrons. What is this 1? This 1 electron. What is the electronic configuration of chlorine? 17, 1s2, 2s2, 2p6, 3s2, 3p5. Or how you can represent 2, 8, 7. You know what is that 2, what is that 8, what is that 7? 2 is here. 8 means 6 plus 2, 8, 5 plus 2, 7. Here we have represented. Then is that 11 stable? No. Nearest element is 10. Is 17 stable? No. Nearest element is 18. Now 11 should become 10. How it will become 10? By losing 1 electron. How 17 will become 18? By gaining 1 electron. You are very familiar with electron dot structure. If you want to represent electron dot structure, you are going to represent like this. Sodium. Sodium means Na. You have to represent electrons. What electrons? You have to represent only valency electrons. That you have to keep it in your mind. How to take valency electrons? Here you see electronic configuration of sodium 1s2, 2s2, 2p6, 3s1. Here we have 1, here 2, here 3. 1 means first orbit, 2 means second orbit, 3 means third orbit. S stands for s orbital, P stands for p orbital. We have remaining 2 orbitals, d orbital, f orbital. This 2, 2, 6, 1 represents electrons, isn't it? Now, what is the valency? Which is the highest number of orbit you can find in sodium? 3. You can draw like this to avoid confusion. 3s1 is the outermost orbit. Outermost orbit. What is outermost orbit? 3s is the outermost orbit. Now, what is the outermost electrons or valency electrons? This one. This is valency electron. Now, how many valence electrons you have? 1. You have to represent 1 with 1 cross mark. That's it. Next, chlorine. Chlorine symbol Cl. You have to draw electron dot structure for the chlorine. To write electron dot structure, valency or outermost electrons you have to take. Now again, while coming to chlorine, what is the highest number of orbit? First orbit, second orbit, third orbit. So this must be outermost orbit. In outermost orbit, what are these electrons? How many electrons are there? 2 plus 5, 7. Now we have to represent 7. How to represent? 1, 2, 3, 4, 5, 6, 7. Now here, if there is one electron, it would become stable. Here, if it is losing one electron, it will become stable. Now what it will do? This electron will be transferred to chlorine. From sodium, one electron will be transferred to chlorine, and that electron will come and settle here, such that 17 has become 18 and sodium lost one electron, 11 has become 10. Now sodium is stable, chlorine is stable. How it has become stable? One by losing electron, one by gaining electron. So that only we will write reaction like Na, after losing electron it will become plus Cl, after gaining electron it will become minus, gives rise to NaCl. Don't represent plus and minus because this atom might be ion. How atom can become ion? How atom can become ion? Either by losing or gaining electron. But while coming to this molecule is always neutral. Always neutral because plus charge minus charge will be cancelled. It is neutral now. To become neutral only, to become stable only, molecules are formed. Now you might have understood what is transferring of electrons from one atom to another atom by losing and gaining electron, that is ionic bond. You can find example for magnesium chloride also. You are very familiar with that. Magnesium atomic number 12. If you write electronic configuration 1s2, 2s2, 2p6, 3s2. Now outermost orbit is 3s2. If you dot electron dot structure, it will become Mg, 2 electrons, 1, 2. Now chlorine atomic number is 17. You know electronic configuration, outermost orbit. How many you can get? 5 plus 2, 7 you will get. And here Magnesium should give 2 electrons. It should lose 2 electrons. How it can lose? Here there will be one chlorine. Here there will be another chlorine. This first chlorine has 1, 2, 3, 4, 5, 6, 7. Second chlorine has 1, 2, 3, 4, 5, 6, 7. Magnesium, one electron can be transferred to one chlorine. Another electron will be transferred to another chlorine. Now magnesium lost 2 electrons and became 10 stable. This chlorine gained 1 electron. Another chlorine gained 1 electron, became 18. Like that, how you can write equation? Magnesium lost means plus 2 electrons, Mg plus 2 or 2 plus Cl minus. You should not write chlorine got 2 electrons. No, chlorine can get only 1 electron, Cl minus. But here what you can do? 2 chlorines got electrons. One chlorine got 1 electron. Like that, how many chlorines? 2 chlorines. Gives rise to MgCl2. That is the equation you have to represent for ionic bonds. Now we are in chapter carbon and its compounds. Carbon and its compounds means compounds where there is combination of atoms. One of the atoms is carbon. Are you getting? Compounds. What compounds? Carbon compounds. In that carbon compounds, one of the atoms is carbon, another might be anything, maybe sulfur, oxygen, hydrogen, whatever it may be. That is the concept you need to understand. Now, carbon is very versatile element. Very versatile element. Now, you have many materials around you. You can turn your head, you can find many materials in your room, in your house, right? Different materials. You can find food materials, you can find furniture, you can find medicine, you can find stationery items, you can find juice, you can find paints, whatever it may be. You can find wood, right? You have pen in your hand, you might have book in your hand, you have mobile in your hand, laptop in front of you. All these materials you can find around you. All materials will have carbon inside it. Definitely there will be carbon. In our human body also, we have carbon. You see, gas, what we are inhaling is oxygen, what we are exhaling is carbon dioxide. Exhale, inhale O2, exhale should be O2, but from where we got this C that is present in our body? Not only in our body, but it is present in almost every substance, in every material. How you can find it? Take any substance, try to burn it. If you burn, after burning, it will become black in color. Might be ash you can get, coal you can get, charcoal you can get, whatever substance you take paper, pen, wood, plastic material, whatever you take. If you burn that substance, it will become black in color. That is the representation of presence of carbon in atmosphere. we have 0.03, just 0.03% of carbon in form of gas like carbon dioxide, carbon monoxide, etc. On Earth crust, there is only 0.02% of carbon in form of substances or minerals like carbonates, etc. You see, not even 1%, not even 0.5%. It is 0.02 on Earth crust, 0.03 in atmosphere. But its uses, its presence is abundance. Lot, huge, in every substance as a compound, as a part of the compound, as a part of the substance, carbon is present. So that only it is necessary for us to understand importance of carbon in our life. Carbon is represented with the symbol capital C. Its atomic number is 6, mass number is 12. 6 is its atomic number. Of course, you know that 12 is mass number. This C is symbol. Now, if you take atomic number, which is represented with the letter Z, atomic number is 6, number of electrons 6, number of protons 6, number of neutrons 6, its mass number is represented with the letter A, is 12. You are very familiar with this, isn't it? You see, it has 6 electrons, 6 protons, 6 neutrons. Now, if you want to find its valency, how you can find? You know valency numbers. 2, that is helium. 10, that is neon. 2 is helium. 10 is neon. This 6 is exactly in between 2 and 10 to become stable. So here, if you observe the chart, what we have discussed, 112 elements are unstable. In that, carbon is also one of the elements, isn't it? Carbon will be trying to get stable. How? By transferring of electrons, we have discussed. Transferring means either by losing or gaining electron, isn't it? Now you see, carbon to become stable, either it should lose 4 electrons or it should gain 4 electrons. So if it is losing 4 electrons, it will become 2. If it is gaining 4 electrons, it will become 10, such that it will be stable. Now the question, what it will do? Will it lose electron or will it gain electron? So, will it lose electron? Will it gain electron? Let us discuss. Answer is, it will not lose electron, it will not gain electron. Neither lose nor gain. Why? Why it cannot lose electron? Why it cannot gain electron? Let us discuss. Okay, we know structure of the atom. This is nucleus. This nucleus has 6 protons, 6 neutrons. Now there is first orbit. Okay, how many orbits we can find in carbon? If you write electronic configuration, 1s2, 2s2, 2p2. So that is right, 6 plus 2 plus 2 plus 2, 6. First orbit, second orbit. So in carbon, how many orbits we have? Only 2 orbits. First and this is second orbit. Fine. In first orbit, how many electrons? 2. In second orbit, how many electrons? 4. In first orbit, we have 2 electrons. In second orbit, we have 4 electrons. 1, 2, 3, 4. Okay. Now let us discuss about losing. If carbon atom is losing 4 electrons, what will happen? First, to remove electron, we need to apply some energy to that. To remove electron, energy should be given to the atom. Energy should be given to an atom. What is that energy? Ionization energy. If you give high amount of energy to the atom, you can remove 1 electron, because you see this nucleus will be attracting all electrons. It will attract all electrons. It is not that much easy for you to remove electron from the atom. Okay, you have applied more and more energy. You have removed 1 atom, let us assume. Now, what is the electron, proton, neutron count? Electrons are 5 because you have removed 1. Protons are 6 because you cannot remove proton, you cannot remove neutron, you cannot divide nucleus, isn't it? Okay, now 5. Now you need to remove another electron, because here what we have thought, we need to remove 4 electrons, right? 4 electrons it should lose 1 electron. You see, to remove 1 electron itself, it is so difficult to remove because high amount of ionization energy should be given. Now let us consider, you have given more and more ionization energy to the atom to remove another element that is so difficult for you to remove. Of course, you are some Iron Man or Superwoman, Wonder Woman, you have given a lot of energy and you have removed another electron, let us assume. After removing another electron, what is the electron count now? 4. What is the proton count? 6. Neutron count? 6. Guys, protons and neutrons are greater in mass and greater in potential when compared to electrons, isn't it? Electrons, fine. In 9th class itself, we have learned 1837 electrons is equal to just 1 proton potential. That much potential it has, proton. 1 proton can attract many electrons. Now you see there are 6 protons, 6 positive charges and 6 neutral charges. Okay, it is neutral, leave it. Now 4 negative charges are there. What will happen? All 4 negative charges eventually will go and fall in the nucleus. Definitely will happen that. If you remember your 9th class Rutherford atomic model, in Rutherford atomic model, he told postulates and there are drawbacks. What is the postulate? Atom will be spherical in shape. All electrons will be revolving around the nucleus like planets revolving around the sun. Center part of the nucleus is, the center part of the atom is positive. Electrons are negatively charged. Okay, that is fine. What is the drawback? While electrons are revolving around the nucleus, electrons eventually loses its strength. After losing, like that he told one postulate. But if electrons are losing strength, what will happen? That electron will go and eventually fall in the nucleus. If electrons fall in the nucleus, what would happen? Total atom would be collapsed, isn't it? Now, after removing 2 electrons, after losing 2 electrons, there are 4 electrons, and all 4 electrons eventually will go and fall in the nucleus because 6 protons will be attracting all 4 electrons. Then atom would collapse, so that it is not possible to lose electrons. Okay, now let us understand gaining. Gaining. Okay, now what is the original electron proton neutron count? Carbon has 6 electrons, 6 protons, and 6 electrons first, right? Now let us add 1 electron. That is also not that much easy to add electron. You have to give some energy to that, right? Okay, we have added 1 electron. Let us guess 7 electrons are present now. What about proton neutron count? 6. 6. Electron count just got increased. Now, if you remember Niels Bohr atomic model, if you see this is orbit, what is the position of electrons, guys? Here you can find 1 electron, here you can find another electron, which is exactly opposite to each other. Do you know why? This electron will revolve in this direction. This electron will revolve in this direction. I mean, both same directions only. Right, both, of course, whatever it may be the direction. If you think that is clockwise, clockwise, anti-clockwise, anti-clockwise, let us assume where it is revolving. VE means electron velocity or velocity of electron. VE of this electron is equal to VE of this electron. Simply to say, every electron will have same velocity. Now, if this electron is revolving, moving with some speed, with the same speed this will move, isn't it? Such that exactly will be opposite to each other. And another condition is charge of this electron is negative. Charge of this electron is, of course, negative. Negative, negative, what it will happen? It will repel, isn't it? It will repel. So that only it will maintain some distance. Okay, let us assume we have added another electron. 8 we have added, I mean 2 we have added, 8 electrons, 6 protons, 6 neutrons. 6 protons cannot tolerate 8 electrons. At the same time, if you see this outermost orbit, if we add another 2 electrons, this electron should rearrange themselves. That should rearrange, isn't it? So while it is rearranging, what will happen? Repulsion will become more. There will be greater repulsion. When there is greater repulsion, there will be greater velocity. When there is greater velocity, that electron's velocity will increase further, such that there will be unbalance in the speed, there will be unbalance in the stability, such that atom would collapse again. So if it is losing electron, it cannot tolerate. If it is gaining electrons, also it cannot handle. 6 protons cannot handle 8 electrons. So that carbon cannot lose electron, cannot gain electron, but how it will become stable means just by sharing electrons. That sharing electron is known as covalent bond. Covalent bond. In this chapter, you are going to learn only covalent bond. From next lecture onwards, we are going to see structures. Meanwhile, try to remember one structure. This is so important. This last 5 minutes is so important. Carbon, it is represented with the letter C. Atomic number 6. Mass number 12. Electronic configuration 1s2, 2s2, 2p2. What is the outermost orbit? 2s2, 2p2. Now, if you draw electron dot structure, carbon, how many valency outermost electrons? 4, isn't it? How to represent that 4? It's your wish. You can represent like this: 1, 2, 3, 4. Or you can represent like this: carbon 1, 2, 3, 4. Or you can represent like this: carbon 1, 2, 3, 4. Or you can represent like this: valency 1, 2, 3, 4. Or you can represent like this: carbon 1, 2, 3, 4. Whatever it may be the place you can represent, but remember there should be minimum 1, of course 0 also, 1, maximum 3 electrons. Only triple bond is possible. I'll explain you. Okay, what is the meaning for this? There is one valency electron here. Always it will be trying to get another electron from some other element or from some other atom. Okay, now small example I will say. CO2. How CO2 is formed? Just if you understand this, everything will be easy. Carbon, oxygen. Carbon number 6, oxygen number 8. Carbon electronic configuration 1s2, 2s2, 2p2. Oxygen electronic configuration 1s2, 2s2, 2p4. Now the outermost orbit is this. For this it is this. Now if you draw electron dot structure for carbon, you can represent like this na: 1, 2, 3, 4. For oxygen, how many you have to represent? 4, 5, 6. 1, 2, 3, 4, 5, 6. It's your wish. However you want, you can represent. Now what will happen, you know? There will be carbon with 1, 2, 3, 4 valence electrons. There is oxygen. There is oxygen with 1, 2, 3, 4, 5, 6 electrons. There is another oxygen with 1, 2, 3, 4, 5, 6 electrons. Now what it will do, you know? This electron from oxygen will share with this electron, and this electron from oxygen will bond with this electron from the carbon. And this side oxygen carbon electrons will bond, I mean share. This side also oxygen carbon will share. Now it will become one atom. It will become one stable atom. Now it will become one stable atom. Now what you have to do is count number of electrons. Electrons means this cross in circle. There are 3 circles, isn't it? In these 3 circles, try to count number of electrons. In this first circle, 1, 2, 3, 4, 5, 6, 7, 8, 8 electrons. In the second circle, 1, 2, 3, 4, 5, 6, 7, 8, 8 electrons. In this third circle, 1, 2, 3, 4, 5, 6, 7, 8, 8 electrons. 8 electrons means 8 electrons in outermost orbit. Whenever there is 8 electrons in outermost orbit, we can call it as octet rule, isn't it? So stable, like that carbon dioxide is formed. So from now, if you see this diagram, you have to represent like this. See 1, 2, 3, 4. What is the meaning of this line? At this end, there is one electron. it will be waiting for another electron at that end. So we have one electron at this end. It will be trying to get stable if any electron is bonded at this end. So at this end electron is there. At this end electrons, it is waiting. That is the meaning. So I have to represent with lines. So this how we can represent 1, 2, 3, 4. This how we can represent 1, 2, 3, 4. This how we can represent 1, 2, 3, 4. This how we can represent 1, 2, 3, 4. Don't worry, tomorrow we will discuss. In next lecture we will discuss everything in detail. That's it in this lecture.